Hello, everybody. Hope you enjoyed your 3-day weekend. Today, we're moving on to something new, but we are going to do pretty much review for this new concept, just a couple of tweaks, okay? So we are going to start with this warm-up, which is going to review slope, okay? Hopefully, you remember the slope formula. If you do not, let me pull it up for you so that you can see it. Slope formula, y2 minus y1 over x2 minus x1. So take just a few seconds and find the slope for these two lines. Hint, they will both be fractions and they will both be negative. Okay, so like I said, we are going to be doing some review. Today, we're going to be reviewing dilations, and all the dilations we're talking about today, we're going to be either finding a scale factor or using a scale factor, okay? Or determining if it's a dilation or if it's something else. Okay, so just a review of dilation, in some of the verbiage, because it's been a while, the original figure is called the pre-image. The new figure is called the image, okay? It's also the original image just has regular variables. The new image has the prime, right? The little hash mark on it. And we're always looking to see how we multiply or divide. We do not add or subtract when it comes to scale factor, okay? Only multiplying and dividing, and then we can decide whether it's a whole number or a fraction. Okay, so to be able to do this, the easiest thing to do is to find a point. And to find a point that crosses right at an XY, and you don't have to guess on what that point would be. So I'm going to use point B just because it's an easy point for me to be able to find. So let me pull up this. I'll move it over just a little bit. Okay, so point B in our original triangle, so in triangle ABC, which is our original or our pre-image, point B is the point 3, 1. And then in our our dilated figure, A prime, B prime, C prime, point B is the point 6, 2. And so all you have to do to be able to determine a scale factor is figure out how they get from the first point to the second point. So if you look at this, remember it's only multiplying or dividing. We're going from this one to this one because the original to the new one. How did they get from 3 to 6? Well, 3 times 2 is 6. How do they get from 1 to 2? 1 times 2 is 2, which means my scale factor, or K, if you remember we used K as our variable for that, is equal to 2. Okay, scale factor is equal to 2. Okay, so I'm going to have you guys practice this one really fast. Okay, figure A is the pre-image, so we're going from A to B, okay, and find a point on it. Figure out how they got there, how they multiplied or divided there. So take 30 seconds to be able to see if you can find this scale factor. Okay, here's another one to practice. This one is going from A, the bigger one, to the smaller one. Okay, again, find points. Like I would probably pick this point right here or this point right here because they cross evenly. Don't pick a point like this because you're just guessing on what it would be. So see if you can find the scale factor for this one. Okay, so we're going to talk just really quickly about the properties of dilations because we're going to look at some graphs. So in order for this to be a dilation, it has to preserve any angle measure. So that basically means that you're going to eyeball it and make sure that it doesn't look totally wonky. Okay, dilations preserve betweenness, and what that means is it means the distance between a vertice and the other vertice stays the same. Okay, dilations preserve collinearity, okay, or I can't even spell that or pronounce that right now. Sorry, I'm tired. And that basically just means that the same points lie on the same lines. Like we're not switching. It doesn't go A, B, C, and then all of a sudden it goes A, C, B. Okay. And that dilations preserve orientation. The shape looks the same. The shape has not changed how it looks. Okay. That's all those mean. So if we look at a graph like this, we would go through and say, okay, are the angle measures about the same? Yep, C and C look about the same, B and B, A and A, just an eyeball. Okay, is it preserving betweenness? Well, the distance between A and C looks like it's about the same the whole time, right? The shape doesn't look different. We haven't changed anything. It still says A, B, C this way, A, B, C this way, and the shape has not flipped. It has not done anything else. So if you can answer yes to all of those, you can find a scale factor, and you can just automatically see that it is a scale factor of 2 because it goes from 2 to 4. Okay, so a lot of this stuff is just going to be an eyeball estimate. Okay, so now let's look at this one. We have A, B, C, D, A, B, C, D. Okay, but you'll notice, yeah, the angle measures look the same. The betweenness looks the same. Are they in the same place? But does the orientation look the same? And in this case, we would say no. It actually went from A, B, C, D to A, D, right? We flipped it. This is actually a reflection, not a dilation. Okay, dilations mean it's the exact same shape. It is just bigger or smaller than the original. Okay, so let's look at this one. Is this one going to be a dilation? And if it is, can we find a scale factor? Okay, so hopefully you were able to see that this is for sure a dilation, right? It's the exact same shape, just bigger. Okay, and this one is a little bit more difficult one to find a scale factor in. You actually take the dilated figure and divide it by the original figure. So the scale factor for this one would be 3/2. Okay, it's not as straightforward when it comes to practice and stuff. We're going to try to keep it a little bit more straightforward, but the main gist is, could you recognize that this was a dilation? Okay, what about this one? Is this one a dilation? Okay, so hopefully you would recognize that this one is not a dilation, right? We have, it probably did change maybe a little bit of size, but really this is a reflection, right? We took a C and now it's down here, where a dilation would look exactly the same. Okay, it doesn't flip, doesn't rotate, it's the exact same shape orientation. Okay, what about this one? Is this one a dilation? If so, what is the scale factor? Okay, so now we're going to talk about using a rule to do a dilation, okay? So that very first line there, D of XY, and then it shows you the rule, that is the dilation rule. So that capital D is a dilation rule, okay? So let me pull up this other screen really fast. So this right here is our dilation rule. So that means that our scale factor is going to be 1.5 or 3/2. Okay, so that means that we are going to be multiplying by 1.5 for each of these original points, okay, or 3/2. It's the same thing. Okay, so 1 times 1.5 is 1.5. Okay, -2 times 1.5 is -3. So that means that new point from the original to the new point is going to be a 1.5 -3. Okay, this second one is going to be 1.5 times 1, so 1.5. And then it's going to be 1.5 times -4, which is a -6. Okay, and then this last one, 4 times 1.5 is 6. And -2 times 1.5 is -3. So that is how you would use the rule with the scale factor to be able to find new points. Okay, for what we're doing right now, we're not going to worry about the graphing part of it, but if you are a visual person, you could graph it and make sure that your answers look the same. Okay, they're obviously going to be one smaller, one bigger, but at least they should look the same if you need that visual confirmation. Okay, so let's look at this next one. Okay, so this next one is using a fraction, and I know sometimes fractions freak people out. There's no reason to let it freak you out, but let me pull up this other screen. Okay, so again, it says we're going to take and we're going to times them by 1/3, so we know that that is our scale factor. Okay, and do not turn 1/3 to 0.33333 because it's going to round inaccurately and you're going to get the wrong answer. So what I'd like you to do is I would like you to do something like this. 3 goes into -3, -1 times 1 is -1. Okay, if I was to write this down here, it would be 3 goes in there how many times? Times that. Another way you could look at it is put a 1 underneath it and you would end up with a -3/3, which is a -1. Okay, do not turn this into a decimal. Another way you could look at it is because it's timesing by 1/3, it is also dividing by 3. So that would be another way that you could recognize this. Okay, so then 3 times 1/3 is going to be 1. 3 times 1/3 is 1. 6 times 1/3 is 2. 3 times 1/3 is 1. And -3 times 1/3 is -1. Okay, same thing if you were to divide by 3. So timesing by 1/3, dividing by 3 is the same thing. Okay, so you guys are going to try this next one on your own. Okay, you're going to use this rule right here for dilation and be able to come up with your new points. Okay, so that is pretty much it for dilations. You guys do have a 2-question exit ticket that you're going to work on, but hopefully this was good review for you from before break, and this is a super easy concept, and you're going to cruise through it. Like always, if you have questions, let me know, and have a fantastic day. Bye-bye.